Welcome to the deep dive. Ever wondered how AI, specifically the kind that understands images and text, these vision language models or VLMs, how they could learn to be, well, less of an overthinker?
Yeah, like how we just know it's a cat, right? You don't run through a checklist in your head.
Exactly. That kind of speed, that efficiency, that's what we're digging into today.
Right. Our mission really for this deep dive is to get to grips with a new way of doing things that's not just making AI smarter, but faster too.
Faster how?
By giving it this crucial skill, knowing when it actually needs to, put on its thinking cap.
Ah, okay. And we're basing this on some really fresh research, yeah.
Brand new. A paper called Think or Not: Selective Reasoning via Reinforcement Learning for Vision Language Models. It's proper cutting-edge stuff.
And it tackles this sort of basic inefficiency we see now.
That's right. Currently, lots of AI systems, they go through these long, complicated reasoning steps, even for really simple questions.
Like using GPS to find your sofa.
Exactly. It works, but it's overkill, isn't it? So this research looks at making AI more adaptable, more selective in how it solves problems.
Okay, let's unpack that core idea then, the think or not problem, as they call it. Sounds simple enough.
It does, but the reality is that most models tend to default to generating those step-by-step explanations for almost every single query.
Even when it's obvious.
Even then. And they found this amazing stat. Amazing and kind of shocking.
Oh, yeah.
In one data set, over half the questions could be answered correctly without the AI generating any reasoning steps at all.
Wow, half. That really puts it into perspective, doesn't it?
Yeah.
It's like asking someone their name and they give you their whole life story first.
Precisely. I mean, think about us. If I ask you your name, you just answer.
Right.
But if I give you a complex riddle, you engage your brain more deliberately.
Sure.
And the researchers saw that even pretty advanced VLMs, they struggle to make that switch on their own. It's not just about being able to reason.
It's knowing when to use it.
Exactly. That seems to be a whole separate skill they need to learn.
So how do you teach an AI that? This is where their strategy comes in, right? TON, think or not.
Yeah, this clever two-stage training strategy.
Yeah, break it down for us, stage one.
Stage one is supervised fine-tuning, SFT. And they do something really interesting here called thought dropout.
Thought dropout. Sounds intriguing. What is it?
Okay, so basically, in this first training phase, you've got examples, right? Questions paired with the AI's potential reasoning steps, the thoughts. And what they do is randomly, they just replace those reasoning steps with nothing. An empty space, a blank, basically.
That's it. Just delete the reasoning sometimes.
Pretty much. It's actually a tiny code change, but the effect is huge. The whole point is to introduce this idea, this think or not format, to the model.
So it sees that skipping the thinking is, like, allowed.
Exactly. It makes the AI aware that skipping reasoning is a valid path. Like a student realizing they don't need to show all their work for every single simple math problem.
Okay, that makes sense. You're showing the answer can just be the answer sometimes. But where did they get the initial thoughts from for this stage? Did humans write them?
Good question. No, they use something they call a reverse thinking strategy.
Reverse thinking.
Yeah. The model itself generates the reasoning, but based on already knowing the question and the right answer. It's sort of like saying, okay, AI, here's the answer. Now figure out how you could have reasoned to get here. But remember, sometimes you don't need to explain it at all.
That's clever.
Yeah.
Okay, so stage one introduces the choice. What about stage two?
Stage two uses a reinforcement learning technique. It's called Group Relative Policy Optimization, or GRPO.
Okay.
This is where the model really learns when to think and when to skip. It starts making those decisions actively.
So it's learning by doing now.
Precisely. With GRPO, the model tries generating different responses, some with reasoning, some without, using that empty think option it learned about in stage one.
And how does it learn which is better?
It gets rewarded if the final answer is correct. And crucially, there's no penalty for skipping the reasoning steps if it still gets the right answer.
So it learns efficiency pays off if you're still accurate.
Exactly. It figures out through trial and error which questions need that deep thought and which ones it can just answer directly. And the TON approach, by allowing those empty thoughts, just gives GRPO more diverse options to learn from during training.
It lets it explore the do-nothing strategy, too.
Right, which is perfect for the easy stuff.
Okay, theory sounds good. But what about the results? Did TON actually deliver?
Oh, the results were really compelling. One of the biggest things was this huge reduction in completion length.
That's the amount it writes, the number of tokens.
Yeah, basically how much text the AI generates. Compared to the standard GRPO, TON cut down the tokens by up to 90% on some tasks.
90%. That's massive. Huge efficiency gain. But the big question, did accuracy take a hit?
And this is the really cool part. No, not only did accuracy not suffer, in some cases it actually got better.
Better? How?
On one task, GOQA, that's math reasoning with shapes accuracy, went up by as much as 17%. They called it a free lunch effect.
A free lunch. Nice. So thinking less actually helped it perform better overall.
That seems to be the implication. Maybe it freed up resources or avoided getting confused by unnecessary steps on simple things, and they saw this consistently.
Across different types of problems.
Yep. Counting tasks like CLER, big token reductions, accuracy stayed the same or even improved slightly. That complex mobile navigation task, AITZ, output length dropped dramatically, like from 3 to 600 tokens down to 900 on average.
Wow.
And it still performed just as well in new situations it hadn't seen before.
So it really seems like the AI is learning to be much more strategic with its processing power?
Absolutely. And they tracked this thing called the skip thought ratio.
Okay.
Basically, as training went on and the model got better rewards, it started skipping the reasoning steps more and more often.
So it was actively learning when skipping was the right move?
Exactly. It wasn't random. It was internalizing when thinking was truly needed.
And crucially, when it did decide to think, was the reasoning still good?
Yes, that's key. When it chose to generate reasoning, the length and quality were similar to models that always generate reasoning, so TON isn't making the AI dumber.
Just more efficient. It saves the heavy lifting for when it's actually necessary.
Precisely. It keeps its deep reasoning ability, but applies it selectively.
That first stage, the SFT with thought dropout, seems absolutely vital then. Did they check if you could just, tell the model to skip reasoning sometimes using a prompt?
They did try that, yeah. They tested a hybrid thought prompt, basically telling the model, hey, skip the reasoning if it's easy.
Yeah.
Didn't really work. Prompting alone wasn't effective. The model just defaulted back to generating the full reasoning most of the time, even when told not to.
Huh. So you really need that initial training phase to embed the possibility of skipping.
It seems so. It really highlights that learning when to think or not is a skill that needs explicit training, embedding that format, not just instruction.
Can you maybe give us a concrete example? How does TON look different in action?
Sure. Think about that mobile navigation task again.
Yeah.
Guiding someone through simple steps like tap the settings icon or scroll down.
Okay.
A standard model might write out, step 1, locate the settings icon, which is usually shaped like a gear. Step 2, tap the icon. Very verbose.
Right.
TON learns to just say, tap settings icon. Skip the fluff for the simple stuff. That's where that 60% token reduction comes from.
But then for something harder.
Exactly. If the next step is complex, like navigate to accessibility, then find the text size option and adjust the slider, then TON engages and provides detailed step-by-step guidance because that actually requires thought.
I see. It conserves its energy for the tricky bits.
Perfectly put. And they had similar examples for counting. Simple picture, 3 apples. TON just says 3.
No explanation needed.
Right. But a complex picture, 8 objects, some hidden, TON then generates a detailed thought process. Okay, I see 2 red cubes, 1 blue sphere partially behind a cube, and so on, to get the right count.
Well, the standard model would explain how it counted the 3 apples too.
Exactly. The baseline GRPO was verbose for both, showing it wasn't being selective. TON adapts to the difficulty.
Okay, so summing this up, TON feels like a really big step towards AI reasoning that's, more efficient, maybe even more human-like, deciding when to really engage the brain.
That's the heart of it, yeah. There's a shift away from just making models bigger or feeding them more data towards making them smarter about how they use what they already know.
And the benefits are clear. Less computation.
Faster results.
And sometimes even better accuracy, that free lunch.
Right.
And for you, listening in, wanting to absorb info quickly but also deeply, well, this research mirrors that, doesn't it?
Mm-hmm.
Sometimes you grasp things instantly. Sometimes you need to work through it. TON is teaching AI that same kind of efficient learning.
Yeah, and it leaves you thinking, doesn't it? If we can teach AI to manage its cognitive effort like this, what other human-like cognitive shortcuts could we teach it?
Interesting point. Moving beyond just raw power toward Cleverness, efficiency.
Exactly. How do we make AI truly smarter about how it learns and reasons, not just bigger? It's a fascinating direction. And for anyone who wants to really dive into the technical details, the code for TON is actually available on GitHub.
Oh, excellent. We'll make sure that's accessible. Definitely something to mull over.